Electric Motor Division, Locomotive Service in Section 12, Introduction to Dynamic Braking System Testing and Setting. The purpose of the publication is to describe dynamic braking to provide testing and setting procedures for the dynamic braking system. The contents of this section are divided into separate testing, the setting, the procedure of for each circuit related to the control of dynamic braking brakes. The procedure are printed in parts to facilitate their use with the locomotive that may be taken with the locomotive service manual as needed with a return for the proper place after the work is completed. General dynamic braking is electrical arrangement used to change some of the mechanical power developed in the momentum of the downhill force for the movement of the train into electrical power. The electrical power is converted into heat, which is blown out through the hatch of the top of the locomotive. The traction motor armature is being geared to the axles rotate whenever the locomotive is moving. During the dynamic braking, the motors become electrical generators. Electrical output with the motor armature then connect with across the fan-cooled resistor grids of the first ohmic value. Armature output is determined by the speed of the armature rotate with the track speed, by the amount of the excitation current flowing in the motor field station coil with excitation current of the motor field controlled by the brake lever, the throttle position by any of the regulating device, the device of the dynamic brake regulator, dynamic braking regulator, sense of the voltage across the one half of the braking grid interprets as the armature grid current. The operator to reduce the field current in order to hold the armature current at the grid voltage the maximum permitted by the equal design. Equipment design it does that whenever the maximum current level is attained, regardless of the brake level position. The graph in Figure 12.1 shows with the maximum traction motor field current braking lever in position 8. Brake effort is increased with the track speed, increased with from 0 to 25 miles an hour. Therefore, braking effort lessens or track speed increases. Braking effort lessens as track speed increases. Braking effort may be considered a negative track effort or draw bar push. The effort can be interpreted with the weight with the volt grade and the force of the momentum moving the train going to make up what is being called the weight. The weight is by itself has performed no function. It merely has the ability to perform useful work. During the dynamic braking, the use of the work is to maintain train speed and slow dynamic training. The work results in the heat of the dynamic. Figure 12.1 shows the dynamic braking curve of 62 to 15 gear rate braking efforts miles per hour. Dynamic braking lever position 3, 4, 5, 6, 7, and 8. Braking effort and the miles per hour. The current is 700 ampere. The grid shortening operating during the extended range dynamic braking decreases total grid resistance. Standard range curve the repeated lower value of each of the braking lever positions. Dynamic braking regulator operates to modulate the traction motor field current to maintain traction motor armature grid current at the maximum of 700 amperes. Brake grids rather than at brake shoes. Do you understand braking effort to consider the terms mass and weight, work of the energy required to lift the weight of the given distance, power of the energy required to lift the weight of the given distance, and in a given amount of time. For example, the very small output engine energy can lift the tremendous weight if given sufficient time. 12.1 indicate the braking effort falls off the train speed increase with above optimum so that because of the design limitations equipment involved theoretically braking effort could increase along with the dotted line standing at the top of the graph but regulating a curve to protect the equipment determining where the brake effort does not remain maximum value but falls and the track speed with the note the following. The maximum braking lever position grid voltage current is regulated with a constant above approximately 25 miles per hour. Constantly the power of volts time ampere dissipated with the heat is constant. The power electrically expressed in the volts and amperes may also be compressed in foot-pounds per second in railroad terms for tons miles per hour. Horsepower AC volts times amperes. 1 horsepower equals 375 pounds a mile over hour. Since the design limitation required for the current dynamic braking resistor for the not exceed maximum to increase the speed factor of the miles per hour with the horsepower formula must be accomplished with the decrease of the weight factor in pounds of the formula in order to maintain the maximum current limitation. This weight factor is reduced by decreasing the retarding force of the traction motor fields. In other words, decrease the magnetic flux induced with the motor field current brings about with the reduction resistance through the turn of the motor armature. Loss of effort is return the armature, but since it turns faster, the higher track speed, the resulting power remains the same while braking effort is decreased. Extended range dynamic braking below optimum speed above about 25 miles an hour. Braking effort declines because of the voltage developed with the motor armature falls below the enough. Then even though the motor field excitation is our upper limit by the law, the I equals REE or current equals voltage over the resistance. Like I'm seeing with the voltage drop of the current can be maintained with a high level only with the reducing grid's resistance. The extended range of the dynamic braking grid system reduces the grid resistance step. The track speed with all extended range dynamic braking systems, all resistor grids connected in series with all the motor armature for the cable carrying the dynamic braking. The current passes through the frame of the two transducers. The coils carrying the AC from the D14 alternator are wound at the cord of the transducer. For the impediment of these coils for the control of the amount of the current passing coil of the transducer frames frames. The output of the AC coils passes through the primary winding of the transformer and involved with is transformed to usable value. With the output of the transformer is rectified, loaded upon the resistor pentiometers. Sorry. Voltage signal with the direction portion of the current of the dynamic braking cable taken with the brush arm of the pentiometers, directed by the sensitivity of the polarized relay. The relays match the signals against the throttle control signal function of the control stepping of the motor operated with the program switching the turn control to pick up the power of the contact. The power contact is located in the hatch adjacent to the grid closely singly in the combination of the short out portions of the total dynamic braking grid resistant, thus making the maximum brake current during the very slow speed. The SD-type locomotive's dynamic braking current also passes through the frame of the voltage operated current bypassed by the OCP that picks up the disabled dynamic braking system on the opening resisting grid, a result of the voltage relay current coil, no current in the system. Alright, Electric Motor Division, Locomotive Service Manual, Section 12A, Dynamic Brake Regulating Warning Circuit Testing and Settings. To test the setup of the dynamic regulation warning circuit, perform the following. Figure 12A1, the locomotive engine of the running of the stop of the controls must be set for dynamic braking. One unit is occupied with extended rated dynamic braking chip with a slide of the resistor 43 with a midpoint on the resistor. The general setting with a recalibrated dynamic braking regulator. After the grid shortening, contactors have picked up no additional setting with the slider is necessary. Disconnect the BKF6 wire from the terminal board 62A1. Connect the positive output lead to the main generator set terminal board 62A1. Connect the negative main generator set output to the terminal lead to terminal board 62A2. Connect the 0 to 500 DC voltmeter to reading the main generator set output voltage. Connect the small scale of the DC voltmeter 0 to 30 volts across the terminal 4 and 6 rate with the control panel terminal number 4 positive. The voltmeter will register the dynamic braking regulator terminals 8 and 2. Connect the main generator set leads to apply the approximately 300 volts for 5 minutes. To warm up the regulating and the warming circuit components. After warm up, set the locomotive with control of the dynamic braking advance the brake lever in position number 1. If the engine is running, engine speed will increase. Adjust the rheostat number 10 from the dynamic braking regulator. Pick up at 305 to 310 volts. Increase the main generator set volt until the voltage appears. Voltmeter connected to the 4 to 6 RCP. If RCP if necessary to the rheostat 10 to obtain the dynamic braking regulation open on 8 to 2, 305 to 310 volts. Rate control panel 4 to 6 on the rate control button. Adjusting the rheostat to obtain the dynamic braking regulator 8 to 2. Open the 355 to 310 volts. Will reduce the main generator set voltage to 0, making the adjustments. Reapply voltage. Check the adjustment. Note, if the locomotive is equipped with a dynamic braking resistor grid other than the basic Allen value with 0.86, the high-speed dynamic braker refers to the appointment of the charts and graph drawing with the dynamic braking wheel and the brake warning relay setting valve. Disconnect the voltmeter of the rate control panel with terminals 4 and 6. Disconnect the voltmeter and immediate scale 0 to 150 volts across the coil of the braking wheel resist rear rectifier with a positive with a twice team of BWR. This will indicate the BW brake wheel auxiliary 8 to 2 contacts. Alright, just rheostat 11 with the brake wheel relay drop out at 330 to 335 volts into the main generator set with voltage drop out the BWR with the BWA auxiliary. Opens 8 to 2 contacts necessary with the rheostat 11 when the brake wheel auxiliary opens the 330 to 315 main generator set with the making the adjustment repair voltage check adjustment. 12. Return the brake level idle to the main generator set voltage 0. Return circuit to normal operation condition. Performing the following. Disconnect the main generator set voltmeter. Reconnect the BKF6 wire to the terminal board 62A1. Disconnect the voltmeter across the BWR coil. Return the locomotive controls to the normal standard standby conditions. This is the dynamic braking working condition with the brake wheel working auxiliary calibration test set. Alright, Locomotive Service Manual, Chapter Section 12, Section B, Electric Motor Division, SD45, Extended Range Dynamic Braking Calibration Test. Procedures in 12.13.1 and 12.13.3, the dynamic braking section must be checked for the calibrated indicator with the Section 9C of the Locomotive Service Manual with the attempted calibrated extended range of dynamic braking system. It should be noted that a voltage value should obtain with the record calibrating existing excitation system used to calibrate the extended range dynamic to provide the current through the brake current transducers BC2 brake current transducers 6 and 7 through the open circuit protective relay OCP position locomotive over the pit, making the following test setup. Figures 12B and 1213B3 and 1213.3. Illustration test setup. Stop the design engine, move the starting fuse, place the local control circuit breaker in the opposition, set the locomotive hand brake, the release the locomotive air brake, make the certain jumper cables or disconnect the other than locomotive units. At the cable connection between the number 1 truck locomotive under the cabling, disconnect the motor cable to A and AA from the underframe cabling class A2 and from the AA2 underframe cables together. Bypass the number 2 traction motor armature, insulate the connection with the isolating sleeve. Desired a short jumper cable that may be fabricated with the facilitate this connection. 4. At the number 2 electrical cabinet, disconnect the MPF1 and MPF wires, 3 wires from the coil terminal parallel power contactor 2. P2, the number 2 electrical cabinet content electrical jumper wires from the positive coil terminal brake contactor B with the positive coil terminal power contactor P2. Remove the arc chute with the brake contactor B with the plate of the insulation between the main contact face for the control of the air set of the dynamic braking current with well flow as shown in figure 1213B2. Return the cab locomotive 8 and to indicate the meter shunt located with the base over the maintained electrical cabinet. Connect the accurate millivolt meter with a scale capable of indicating 1,000 amperes. The indicating meter shunt is rated at 1,000 amperes, 15 millivolts, and AA2 side is negative. Disconnect the MBP wire from the positive terminal and transfer. Or you have your insulation cables to the number 2 traction motor AA2 and AA2. Your 100,000 amp, the 15 millivolt indicating meter shunt negative. Jumpers MP1, MP3, MP and motor 12 brake resistor 13, 2 current flow with a braking current transducer, and over current protector. Alright, switch from the M12 to allow the M45 remain dropped with the M12 with energized connection with the jumper wire. To connect the electrician jumper wire for the conveniency of the parallel PA wire terminal with the positive coil terminal M12. Transfer switch pick up when the local control circuit breaker is closed. Connect the electrician jumper wire with the terminal CD with the M12 to enable the pickup of the power contactors. Connect the electrician's jumper wire with the terminal L1 to the terminal L2 with the braking relay. Enable the pickup with the 13 switch with the selector valve with the index in the B position. Remove the air chute with the power with the S14. Place the thin strip of the isolating material from between the main contact face of the material should be thick enough to provide adequate insulation thin enough to allow the contactors to interlock with the function properly. Do not replace the arc chute while insulating remains in the contact faces. Disconnect the EBZ wire from the terminal board 65A6. Check the figure 1213.3. Disconnect the LOR coil from the performance control panel. Disconnect the EBS wire from the terminal board 65A3. Disconnects the IRR increased resistant rectifier coil from the 24T transformer. Alright, disconnect the 24T wire with the detecting terminal board 65A2, but disconnect the DRR from decreased resistant reactor coil from the 24T wire. Connect one end of the tap with the 100 watt test rheostat with convention for the NA wire terminal. Position the rheostat brush for the NA wire terminal. Connect the other end of the tap with the rheostat terminal H for the power of the contactor S. 6 to make the connection here with the help to prevent the rheostat overheating during the testing. Connect the EBZ wire previously disconnected with the TBS terminal board 65A6 to do the brush arm with the test rheostat. Connect the 0 to 150 volt DC voltmeter from the center of the tap tester rheostat. Convention BN wire to place for replace the starting fuse and place the local control circuit on the on position. Start the diesel engine, allow it to warm up. Set up the locomotive controls for the dynamic braking operation, but do not overance the brake lever at this time. Alright, a lockout relay out of lockout relay or LOR calibration. Calibration of a lockout relay pickup that must be proceeded with the calibration dynamic braking installation system indicated within section 9C of the locomotive service manual. Voltage value obtained with recorded adjustment of resistor 8 until it's equipped with the performance control panel. After the adjustment of the rheostat 3 with the SD40 units equipped with the acceleration control panels achieved the calibrating of the low lockout relay pickup of this voltage with vary from one locomotive to another. Usually any value but other than one actually measured may cause the cycling grid shorting contactors. Alright, 22. Connecting the 2000 ohm 100 watt resistor between the number 2 lockout relay with the convention convenient with a 9A wire terminal to provide the current path and negative and to obtain the meter needle for the deflection and indicate the next steps. Connect the electrician jumper wire from the terminal number 8 to the terminal number 2 on the increased resistant reactor for the reactor. This provides the feed for the low lockout relay. No contacts. The locomotive air brake must release to provide this feed. Connect the 0 to 150 volt DC voltmeter positive lead terminal number 8 lockout relay and the connecting negative voltmeter to the lead terminal number 2 lockout relay. Movement of the meter needle to 0 to indicate the lockout relay closer to 8 to 2. Moving the brake lever to about obtain 700 amps of the brake current transducer. The lockout relay contacts will close to 866 voltmeter indicating 74 volts DC. Adjust the rheostat with the RH12 for the picking up the 700 amp the current with the lockout relay 3 at the BN voltage. Current through the brake current transducer 700 amp is operate with the 2S rheostat. Increase the voltage. Lockout relay terminal 3 lockout relay should close 8 to 2 with the meter reading going to 0. Lockout relay terminal number 3 and the BN voltage is to be at the value of the recorded with the tracking adjustment with the resistor 8 and rheostat 3 in section 9 of the locomotive series manual. And necessary with adjust the rheostat 12 with the proper pickup to return the brake lever into the idle position, making the adjustment, but then recheck the adjustment, repeating the previous steps. 28. Return the braking lever to the idle position. Disconnect the jumper in the instant. Increase the resistant reductor terminals 8 and 2. Relay. Your increased resistant relay or IRR calibration. Disconnect the test rheostat brush arm from the lead ABZ wire. Connect the 24T wire previously disconnected the terminal 65A2 with the EBZ wire with the remaining disconnected. Disconnect the voltmeter of the lockout over the relay terminals. Connect with the increased resistant relay terminals 8 and 6. Disconnect the lead from the 2000 ohm resistor lockout relay terminal number 2. Connect the lead with the instant increased resistant relay terminal number 6. Advance the braking lever until the engine speeds. Increase the increased resistant relay and decreased resistant relay will close at 8 to 2. The brake program still switch will not stop until the lockout relay circuit is disabled. Adjust the test rheostat to apply 868 volts to the T24T wire. Adjust the rheostat 9 with the pickup between 625 to 645 amperes. Hold the voltage at the T24T wire 68 volts. Move the throttle lever toward the maximum brake position. Increase resistant relay closes 8 to 6 meter will be given to 0. Increase current between 625 to 645 amperes. And necessary the rheostat 9 to obtain current pickup to check for the adjustment with the increasing the current. Return the braking lever to low in position. Disconnect the voltmeter resistor lead for the terminal number 6, the increased resistant relay, and connect the terminal to the number 2 increased resistant relay. Hold the 22 volt T voltage at 68 volts. Advance the brake lever to the maximum. Reduce the brake. Observe the amperage for the increased resistant relay. Contacts 8 and 2. The meter needle goes to 0. Contacts should be between 8 and 2 below 625 amps. This is the only way to check no adjustment is to be made. Decrease resistant relay calibration. Return the braking level to idle. Return the 100 ohm to 100 watt test rheostat brush arm negative terminal. Disconnect the voltmeter. The increased resistant relay terminals. Disconnect the across the decreased resistant terminals 8 and 2. Disconnect the lead with the 2000 ohms resistor. Increase resistant relay terminal number 2 and connect the decreased resistant terminal to number 2. Connect the jumper wire from the terminal of number 8. Increase resistant relay with the terminal of number 2. Lockout relay with this ensure that the feed with the decreased resistant relay contacts enable the step of the braking program switch. 42. Moving the brake lever to the maximum brake position. Brake program switch remain in number 1 position. Adjust the rheostat 13 with decreased resistant relay 8 to 2 closed between 530 to 550 amperes. Operate with the test and rheostat with amplified 68 volts at 24T wire. Then move the throttle to decrease the current. Meter should not go to zero. The brake the program switch should set up with the position number 1 and 2 in position. Will continue to position number 6 on the decreasing current between 530 and 550 amps. If it's necessary, adjust the rheostat 13 RH13. Check the adjustment and on the decreasing current. Adjust the rheostat 14 on the decreasing resistant relay. Close the 8 to 2 between 485 to 505 amps. Hold the 24T voltage at 68 volts. Move the brake lever to further reduce the current. Meter and needle should deflect. And the brake the program switch step from the position number 6 and the number 9 position. To the number 9 position, decreasing the current 485 to 505 amperes. If necessary, adjust the rheostat 14 RH14. Check the adjustment on the decreasing current. Return the braking lever to idle position. Center the reverser position 100 ohm, 100 watt. Test rheostat brush in the negative terminal 46. Disconnect the jumper wire between the increased resistant terminal number 8 and low lockout relay terminal number 2. Disconnect 2000 ohm resistor and voltmeter of the decreasing resistant relay terminals. For your OCP relay or calibration and check. Although the test setup remained, it was also extended the range of dynamic braking calibration. Perform the following. Verify the OCP operation. The number 2 electronic cabinet figure 12B4. Disconnect the ASX2 wire from the K terminal of the OCP. And connect the high voltage negative output terminal with the MG set with the K terminal. Disconnect the A52 wire from the top of the terminal, the rheostat 92B with the rheostat 92C, or connect with the high voltage positive output lead with the main generator set resistor terminal located at the A52 wire. Connect the positive lead with the O1500 DC voltmeter to the top terminal, the rheostat 92B or rheostat R92C. Connect the voltmeter needed in negative lead terminal K of the OCP. Connect the MG set of positive low voltage input, the number 1 upper terminal board TB93 with the connect the negative low voltage input lead to the number 1 terminal in the terminal board 93. Move the locomotive cab, disconnect the 24A6 wire from the number 1 terminal rate control panel. Alright, shows the 12B4 location of the component for the OCP check. Disconnect the lead with the center tap of the 100 ohm test rheostat connection to the number 1 terminal of the RC rate control panel. Position with the rheostat brush arm at the negative terminal. Set the control dynamic brake operation. Advance throttle far enough to increase the engine speed. Advance the test rheostat above. Obtain 200 amps current with the cable bypassing the OCP current reading of the meter. Connect with the indicating meter shunt figure 12B2. Adjust rheostat 92B. Apply with the main generator set voltage until the OCP picks up the contactor B with the P2 power contactor 2 P drops out. OCP should pick up between 840 870 volts with 200 amperes from the bus through the OCP frame. Necessary to reduce the main generator set voltage to 0. Adjust the throttle idle position. Adjust the rheostat 92B for the proper pickup of the OCP. Recheck after adjustment. Alright, after the pickup of the 200 amp of the correct operate with the rheostat with the past 400 amp for the bus bar through the OCP frame with the rate of the main generator set with the OCP should pick up between 1110 and 1140 volts. There should be no adjustment made. This is check only. No, if the pickup with the value out of tolerance, recheck the pickup with low current. Repeat the check with the higher current. The OCP relay pickup the value if it can be brought with a tolerance to the high low current relay is defective. Should be replaced with a qualified relay. Removing the suspected faulty relays, making certain that the cold hold down spring under the magnetic tie bar properly positioned is not in separating the coil core from the magnetic tie bar, making certain that the tie bars are securely properly applied with the proper brass screws, non-magnetic shims, and pin with the tie bar position against the magnetic core. Our return circuit to normal operation condition by performing the following. Start the diesel engine, remove the starting fuse, place the local control circuit breaker in the off position. At the number 2 traction motor, reconnect the A with the A2 and the AA with the AA2. Apply the proper insulation sleeve with the clamps. See, at the end of the number 2 electrical cabinet, disconnect the main generator set of the voltmeter, reconnect the ASX2 wire to the K of the OCP, reconnect the A52 wire to the top of the terminal rheostat 92B with the rheostat 92C. Remove the insulation between B and the contactor R tip to play for the arc chute. Disconnect the jumper tape from the terminal with the B2 and power contactor 2. The base for the number 1 electrical cabinet. Disconnect the millivolt leads of the indicating meter shunt. Secure the indicating meter leads in place. Disconnect the jumpers between the positive coil terminals M12 and the PA and the L1 and L2 of the BR. Brake relay. Disconnect the MP wire from the positive terminal of the M12. Disconnect the jumper between C and D of the M12. Remove the insulation of the S14 main contacts to replace the arrow chute. Disconnect the text rheostat voltmeter. Reconnect the 24A6 wire of the number 1 terminal of the rate control panel. Reconnect the EBZ wire to the terminal board 65A6. Reconnect the EBS wire to the terminal board 65A3. Reconnect the 24T wire to the terminal board 65A2. Run locomotive controls to normal standby conditions. Alright, here's electric motor service department, locomotive service manual, section 12, part C, dynamic braking, motor field protection, testing, and setting. Alright, procedure. Early in model set SD40 with the SD45 locomotives with a wheel slip, the wheel creep relays with a wheel slip control, equipped with the motor field with a protective circuit to make the wheel creep relay operating coil with the circuit that requires calibration. Late model of the IDAC wheel slip control and equipped with a special temperature compensate closed tolerance motor field protective relay of the MFP motor field protective relay that requires no circuit calibration. However, the earlier units modified with the IDAC wheel slip may be used of the wheel grip relay with the type of the relay, the motor field protection, and the circuit requires calibration. The following includes the instruction testing with each type of circuit to provide the instruction for the calibration wheel grip relay circuit. Units with the wheel grip relay and motor field protection. Perform the following tests on a set of the wheel grip relay motor field protection circuit. See Figure 12C1. Note: do not change the setting of the rheostat 66B, resistor 66B, or resistor 67B during this procedure. Remove the generator field fuse. Start the diesel engine. Set up with the control dynamic braking option. Disconnect the ground shunt generator generator shunt wire with the terminal board 68B6. Connect with the high voltage pipe with the output with the lead of the main generator set through the ground shunt wire. Connect the negative high voltage out of the lead. The main generator set negative test and connect the 0 to 150 volt DC with an MG set voltage. Connect the test lamp across the generator field. Current detector coil lamp will go out with the generator field will drop out with the wheel creep relay picks up. Connect the main generator set low voltage and the input lead to the main battery switch. Apply 75 volts to the main generator set for about 5 minutes to preheat the circuit components. Advance the dynamic braking level until the engine speed is increases. Adjust the rheostat resistor 62B with the wheel creep relay picking up between 78 and 82 volts. Increase the main generator set voltage. Wheel creep relay should pick up the test lamp between 78 and 82 volts. As necessary for the main generator set voltage 0 and adjust the slider of the resistor 62B. Reapply the main generator set voltage to check the adjustment. Return the circuit to normal operation condition. Performing the following: disconnect the main generator set and the voltmeter. Reconnect the ground shunt with the terminal board 68B6. Return the locomotive controls to normal standby condition. Test the reconnecting generator field and fuses. Wheel control wheel creep relay motor field protection system. Resistor to resistor 62B and 61A. Brake reductor auxiliary relay. Resistor 66C and resistor 67B, battery AB, battery positive A223, resistor wheel grip relay wheel slip, negative test jack, main generator set plus. Alright, units with the IDC motor field protection relay. From the following test function, the motor field protection relay move the generator field fuse, start the diesel engine, set up the locomotive control dynamic braking operation, allow the brake lever to remain in idle position, insert the telephone plug 7/32" rod into the test jack, circuit the breakers, panels, connect the output with the main generator set, the test jack, connect the 0 to 150 volt DC leader, read the MG setting out voltage, connect the test lamp across the generator field contactor coil, test the lamp, go out with the generator field contactor will drop out when the motor protection field picks up. Set up the locomotive control with the dynamic braking operation. Vamp the brake level until the engine speed increase the main generator set voltage. The main motor protection field current picks up. Drop the generator field. Turn off the testing of the lamp with the should occur with between 78 and 82 volts. Relay pick up of the tolerance replace. Relay with a qualified relay. Disconnect the main generator set with a voltmeter test and the plugs. Return the locomotive control normal to standby. Used with IDC wheel creep relay type motor field protection. Perform the following tests and calibrate the motor field protection circuits units equipped with the IDAC wheel creep relay type motor field protection relays. Alright, remove the engine generator fuel fuse, start with the diesel engine, set up the locomotive control dynamic braking operation, allow the brake lever to remain in idle position, insert the telephone plug 732 inch rod to test jack with the circuit breakers panel 3, connect the output with the main generator set with the test jack, connect with 0 to 150 volt DC with read the main generator set with the field output voltage, connect the test lamp across the generator field contact with the test lamp, goes out with the generator field contact to drop out when the main motor field protection picks up. Set up the locomotive control with the dynamic braking operation. Allow the brake lever to remain in idle position. Connect the main generator set at low voltage. Leave with the main battery switch. Apply a 75 volt to the main generator set for the 5 minutes to preheat the circuit per components. 7. Adjust the dynamic braking lever with the engine speed of the concrete. Adjust the resistor at 62 with the main motor field protection. Pick up 78 to 82 volts. The main generator set voltage wheel creep relay will pick up with the test lamp goes out between 72 and 82 volts. If necessary, the main generator set voltage is 0. Adjust the slider to resistor 62B. Reapply the main generator set voltage. Check the adjustment. Disconnect the main generator salt and set voltage test plugs and test lamp. Return locomotive controls to normal standby conditions. Alright, that was actually introduction section 12, the locomotive section 12.